We know from the previous video when we tried to find the partial fraction decomposition, we're essentially looking for three constants a, b, and c. And we know that the denominator here can be broken up or factored into the three prime linear factors, x, x plus 5, and x minus 5. So now the technique here, once again multiplying both sides by this denominator, x to the third minus 25x, eliminates this denominator on the left side and makes just the numerator by itself and with no fraction. So now basically what happens on the right side is that a multiplies all the factors except its own. And the reason for that is because when you multiply both sides by this denominator, you can think of it as this one instead of that one because it's equivalent, it's just a different way of writing it, right? We took the x out. Notice that when a multiplied this, the x's would cancel out, right? So it would just multiply x squared minus 25, meaning it would multiply just these two factors, right? These denominators except its own, right? So x plus 5 and x minus 5, like that. And the same thing for b and c, right? So the b multiplies all the factors except its own. So it's going to be x times x minus 5. And then the c multiplies all the factors except its own. So x times x plus 5. So instead of just trying to traditionally compare the coefficients of the respective powers of x on the left and the right side, you notice that since coefficients for each individual power of x must be equal on both sides of the equation for all x, you realize that you can find any x, any suitable x that will work, and then simply solve that way. So what I mean is that when x is equal to 0, notice that these two terms become 0 because they're both multiplying the x squared and x respectively, right? So what remains here is minus 125. And setting x to 0 also eliminates these two terms here because they both multiply the x's, right? So instead all you have is this. X is equal to 0 makes only 5 and minus 5 remain, which multiply to give you minus 25. With the a, it's minus 25a. So you see that actually solves for a immediately. Dividing both sides by negative 25 gives you the a value of 5. So now what happens is the next value of x that's going to work is going to be 5. Now why is that? Because realize that being 5 inserted into this factor x minus 5 makes this into a 0. 0 multiplies by anything here gives you a 0, right? So this is gone and this is gone as well for the same reason, because there's a factor of x minus 5. So the only thing that remains is this one, right? So 5 for the x value plus 5 is 10. 10 times the 5, the x value is 50. So 50c is on the right side of this equation. Now on the left side, it's going to be a little harder, but not too hard. 5 squared is 25. 25 times 4 is 100. Right? So 100 minus 15 times 5, right? So 100 minus 75, okay? So that's 25. 25 minus 125 is negative 100. So as a result, dividing both sides by by 50 gives you c is equal to negative 2, right? So that's the c value that we found. So the last one that we're going to compare, the last x value that we're going to use to compare both sides is going to be x value of negative 5. And why negative 5? Because we have the factor of x plus 5, right? X plus 5, two factors there. Inserting negative 5 for the x makes this whole thing 0. This factor turns into a 0, and so does this factor. So these two, the first and the third terms, are all 0 except this second term. Minus 5 minus 5 is minus 10. Minus 10 times the x value of negative 5 is 50, right? So 50b is on the right side. Now on the left side, not too hard. Negative 15 times negative 5 is 75. 75 minus 125 is minus 50. Minus 50 plus 100 is 50, right? Because this thing is 100 with a negative 5 for the x. So this is 50. So as a result, dividing both sides gives you the value of b. So the b is 1. Right? So as a result, you can see that it's going to be the same thing as in the previous video. 5 divided by x plus 1 divided by x plus 5 plus minus 2 divided by x minus 5. So the answer is absolutely the same using an alternate method. So thank you so much for watching, and hopefully this was fun, and I'll see you in the next video.